In this video, we're going to introduce you to ggplot2, an R package that can be used to produce data visualizations, like the one on this title slide. ggplot2 is based on the grammar of graphics philosophy, which supports building up plots in layers, starting at the bottom with data, aesthetics, and geometry, and ending at the top with coordinates and themes. This video will show you how to load and install the ggplot2 library of functions, and will then introduce you to the first three layers of graphics, data, aesthetics, and geometry, by creating a histogram, a box plot, and a bar chart. We'll conclude with a final example that will demonstrate how to build in the other four layers as well. By the end of the video, you'll be able to produce both of these plots on the title slide. To install the ggplot2 package from RStudio, navigate to the Packages tab and then click Install. Type in ggplot2, make sure that Install Dependencies is checkmarked, and then hit Install. I'm not going to complete this step because I already have it installed on my machine. After the installation is complete, navigate to the Packages tab again and type ggplot2 into the search box. Make sure that the check mark next to the box for ggplot2 is highlighted. If not, you will not be able to access the functionalities from this package. To demonstrate the use of ggplot2, we're going to be using the same students 15 dataset from our numeric variables in R video. We'll start by making a histogram of the risk score variable. As mentioned in the introduction, ggplot2 takes a layered approach to graphics, and the first layer is data. So we're going to begin by creating a core ggplot object, which takes our data frame, students 15, as its first input. The second layer is what we call aesthetics. Aesthetics are mappings of variables in our dataset to different aspects of our plot. For a histogram, we only need one aesthetic, which is the x variable. In our case, that will be risk score. Finally, the third layer is geometry. Geometry is just basically telling ggplot what type of plot you want to make, which in this case is a histogram. After hitting enter, we'll see that a histogram of the variable risk score will appear in the lower right-hand corner. Before we talk about how to further customize this plot by changing bin width, axes labels, color, and fill, and whatnot, I'll note that you can actually simply change this to a different geometry, for example box plots, by adjusting the second part of our command. Notice that in this case, it's a horizontal box plot, and that's because we supplied risk score as an x aesthetic. If we change it to a y, then we'll get the typical vertical box plot that we've been discussing in class. Similarly, if you would like to create a box plot for comparing groups, you can add in an x aesthetic, which is a grouping variable from our dataset, for example class standing, and now you'll get a box plot of risk score broken down by the different class standing values. One of the advantages of ggplot is that it's easy to customize and change plot properties. For example, suppose, going back to our histogram, that I would like to change my bin width to some smaller number to create a better plot. I'd also like to change the color of my bars to orange, and I'd like to outline my bars in black. That can be accomplished by adding some additional variables to the geom histogram. We can also play around with the axes and scales, for example, by changing the x label to risk score. And finally, if you don't like the gray background, you can mess around with the theme of the plot, for example, to change it to a black and white theme. Please Google themes in ggplot to find out more options for this last command. We're going to conclude this video by showing a more complicated example that will actually use all 7 layers of the grammar of graphics. We're going to be building up a bar chart which will show class standing broken down by risk level. It starts relatively similarly to the histogram example from earlier in this video. Notice that we've defined a core ggplot object which takes a data frame, namely students 15, and an x aesthetic, namely class standing, and adds to that a bar geometry, producing the graph shown in the lower right-hand corner of the screen. The first thing we're going to change about this is to add facets to this plot. Facets are the fourth layer of the grammar of graphics. In a facet, you add a new variable to a plot which splits a previous one into panels that can either be in side-by-side configuration or a vertical configuration. To get the side-by-side configuration, we're going to use the facet grid function and use the notation that will take our current plot, represented here by a dot, and break it down by the values of the desired variable, in this case risk level. To switch this to a vertical configuration, simply switch the roles of risk level and dot in the previous command. But I kind of prefer the side by side, so we're going to go back to that one for now. In order to make this plot look nicer, there's a few things we'd like to change. First, I would like to add some color to the different bars, and that can be done by introducing a new aesthetic called fill. With fill, what we're going to do is add class standing again into our plot as a fill variable. This as a factor one just makes sure that it's actually a discrete valued instead of a continuous valued variable. Notice here that this doesn't look so nice because we have this long title as.factor class standing at the top of our color chart. In order to fix this, and also to motivate what we're going to be doing next in switching this to a relative frequency chart, we're going to have to modify the title on this graph, and that introduces yet another layer in the grammar of graphics, the scales layer. In the scales layer, we manipulate objects in our plot. We in fact manipulate aesthetics, whether they're x-axis variables or y-axis variables or fill variables or grouping variables, by appropriate commands. In this case, what we're going to be doing is changing the name on the top of this bar to just say class, and I'm also going to be changing the color values to black, orange, blue, and pink. The syntax here, scale, fill, manual, means that I'm applying a scale function to the fill variable, and I want to manually assign these 4 values to the 4 different levels of the variable class standing. This last one, name class, will change the title at the top of that bar. And you notice this is already starting to look like a much nicer plot. In order to switch this to a relative frequency scale, we need to apply yet another layer, which is a statistic layer. Notice right now, we've kind of subtly already done that in summarizing these variables by counts, but now I'd like to summarize them by proportions instead. In order to do this, we have to introduce yet another aesthetic, the grouping one. The grouping one has to be equal to the values of my facet variable, in this case risk.level. And that's because I want to actually compute the proportion of freshman, junior, sophomore, senior inside of each different level of the risk level variable. That's a lot of levels to deal with. Second, we're going to summarize our results as proportions instead of the default of counts in our bar charts, which can be done with this command, y equals ... prop ... Actually, you can also put stat prop here if you would like, but we'll use this older notation instead. Notice here that it overrided our fill values, that I no longer have colors, but on the plus side, I do have proportions now on my y-axis. Now, continuing on, to change these values to percents, what I need to do is affect the scale on the y-axis. So I'm going to add to this a command scale y continuous labels percents, which will change the y-axis to percentages instead of proportions. And then we'll adjust the labels on this axis so that the x-axis now labels class and the y one labels percentages. We're almost done, but we'd also like to add numbers on the top of these charts to actually state what the percentages are. And I'd also kind of like to get my color variable back in there too, because you notice it sort of disappeared. So let's take care of the first problem, which is adding the numbers. Adding the numbers, which is also part of the statistics layer, involves adding a text geometry to the object. You can see that this is getting to be quite a complicated function, and I'll make sure to post this final product in the video description so you can do this on your own. The aspects of this geom text command was: 1, I defined a label aesthetic which says to store the scales as percents. 2, I actually specified where on the y-axis I want those labels to appear, which is at the proportion values. 3, I said I want to use the stat count to do that. And 4, I want to adjust them so that they actually appear above the bars instead of on them, and this -0.5 accomplishes that task. It might look like they're kind of running off the page here, and they are. However, notice if you zoom in on the plot, you can see them just fine, and you can adjust this and scale it to whatever you need for a paper or whatnot. Finally, in order to fix the color aesthetic, what we have to do is go back here and actually add the fill variable at a different stage in here. Because now, instead of specifying it before I do the grouping, I actually want to specify it as a value inside the aesthetic related directly to the x variable in my plot. And now you'll notice my colors are back. And if I zoom and create a big enough plot window here with the right proportions, then voila, we get the nice looking plot from the PowerPoint slides. That last one's quite a mouthful, and I'm not exactly expecting that you'll take in all that on a first try. However, hopefully, if you study this video a few more times and perhaps practice building up these types of commands over and over again, you'll get used to using ggplot and realize it for the powerful tool that it is in creating customizable graphics.